Okay, wonderful. Thanks everyone so much for joining us for our September speaker series. I am absolutely thrilled to introduce, is it Easton LaChappelle?
You got it.
Yay! All right. So Easton is the founder and CEO of Unlimited Tomorrow. And just a little description. When LaChapelle was 14, I think this is such a great story. He made his first robotic hand out of Legos, fishing wire, and electrical tubing. The hand turned into an arm with the gradual improvements and then advanced to a 3D printed brain powered robotic arm. My goodness, that's incredible. After an encounter with a 7-year-old girl at a science fair whose prosthetic arm had cost tens of thousands of dollars, LaChapelle was inspired to solve this problem by creating a practical and affordable device. So this is I'm so excited for this September speaker series. This is, I think, our third or fourth one with Mesh Labs. So if you are someone outside of Mesh Labs and you're joining us because you saw a LinkedIn post or an Instagram post and you clicked on the QR code, we're so happy that you're here. We'll be having the speaker series regularly. Mesh Labs, if you're not familiar with us, we are a media production studio. We do XR media production, so augmented reality, virtual reality. We also do mobile application development. And we're here within the Herberger Institute for Design and the Arts within ASU. And we have all of our development work is done with student workers, ASU student workers. And part of our infrastructure is a guild system. And so these guilds are small groups of like-crafted students that all focus on a certain area of the creative production process. So we have 3D modelers, spatial engine integration, spatial audio integration, project management, narrative design. Don't get your feelings hurt, guild members, if I did not say your guild. It's a lot of guilds. But the purpose of the speaker series here is really several fold, but one is that these are a benefit to the guild members. We try to bring industry leaders and different industry experts into our guild program so that our guild members and our Mesh Lab student workers can interact with the most cutting edge technology. And Unlimited Tomorrow and Easton, I can't think of a better example of cutting edge technology than what we're going to be seeing today. So with that, thanks everyone for coming. Absolutely so thrilled to have you, Easton. I'm going to let you take it away.
Amazing. Thank you, Sky. And thanks everybody for joining today. I think we're gonna have a lot of fun. I really want to take you through the full journey from my early days of creating and using Arduinos in my parents' bedroom to where we are today with the company and developing many sorts of different products, all really built around human augmentation. That's really my passion, and I think where a lot of energy will continue to go in today's world, and it can unlock some beautiful things. So I'm going to start at the very beginning where this is little Easton, if you will. I think I was about 14 or 15 when I started making my first robotic things. For context, I grew up in a tiny little town in Colorado. Population's about 1,000 people. My graduating class of high school is about 23 kids. So teeny tiny little place. And I would pretty much run home from school, bored from the education system and starting to tinker and starting to teach myself how to write software, playing around with 3D modeling. And this was right at the time where 3D printing was starting to become a little bit more mainstream, or just it existed at a consumer level. And just even thinking about that, it really changed how I thought about creating and turning ideas into reality. And I was always looking for a project. Every year I would use science fair as an excuse to make something cool. And I think if I remember correctly, my seventh grade science fair project was I made a coil gun out of disposable camera capacitors, and did different tests to see, the efficiency and how far the metal object would be thrown. And then for my eighth grade, I made this project, which was a very, very simple robotic hand, but it was controlled by a control glove. So it was essentially a teleoperated robotic hand. So as you can see, there's little flex sensors that I hand sewed onto a hardware glove. I have an Arduino, and there's actually the very first PCB I made. There's a method where you can use a Sharpie to draw onto raw copper board and then etch that in acid, and the acid will eat out all the copper except for where the Sharpie is, and then you can pretty much hand draw PCBs. So I had to get a little creative with limited resources, but ultimately piece things together. And for me, this was really, kind of like the first project that, I saw the potential, and it really made me excited. And throughout kind of learning, this was a very difficult thing to just run home and start, learning, XB radios and Arduino coding and controlling servos and different things like that without, teachers and things like that. But I mostly turned to the internet and found a lot of online forums, and just like-minded people that I could collaborate with and study open source projects. And at the time, I actually made this first project open source. I made an instructable so you can go online and download the code, and I gave step-by-step instructions on how to make it. And I owe a tremendous amount of credit to the open source community and what it's done for me. And it was because I started sharing my creation. I made a little YouTube video, put it on Instructables. It's ultimately how I got an email from Popular Mechanics one day, and they wanted to feature me in one of the centerfold images. I think it was 2012. I think it was maybe like April of 2012, I think was maybe the edition. But this is the photo from Popular Mechanics, and I think it embodies kind of my brain in a very great way with all the Legos and cobbled together pieces. And I look back at that, and it's really cool just to see that perspective. But I quickly caught the bug. I wanted to make something bigger and better, right? So I mentioned 3D printing was just starting to hit the consumer market back in the MakerBot days, still around the 2012 era. And 3D printing was really simple and fairly primitive back then, but it was still a box that you could design and make anything, and more or less it would produce it. And what that does, I think, to your mind when you were thinking about problem solving and just creating in general, it's a really tremendous perk that you can really use. And so I really leaned into that. I said, hey, this is a really simple robotic hand. I have a proof of concept. I have a strong foundation of knowledge built. I know how to move servos. I know how to read sensors. I can send that wirelessly. I can, make something cool come from that. But now, hey, can I actually, make something, more functional? Can I make an articulated robotic hand with maybe an opposable thumb, and start kind of leveling up, ditch the Legos and electrical tape and maybe use some metal and some other materials like that. And then I just quickly found my groove and continued to make what turned into a robotic hand all the way to a robotic arm. And a couple funny things along the way. If you look closely, the elbow motor of this robotic arm is a motor from a car. It's a windshield wiper motor, and I turned that into a servo motor. I stuck a potentiometer to the end of that. So now I have some sort of positional feedback, and then software I could tell it go to this degree, it would go to that, and PID and all that fun stuff, and cobble together something that probably would have cost hundreds of dollars for probably 50 cents. So there's some cool things that just again had to be creative. Um, but I found that it was easy. It was easier for me to break the project down into smaller chunks. I mean, this is still like, when I look at this now, I can see it. I mean, there's a lot going on. From the software to move things, how you actually instruct it to go to different positions, the mechanics, everything has to work in unison. And for me, I found it was much, much easier to break this project down into bite-sized chunks. And that made the project less intimidating and easier to approach. And I think failure was always part of everything. I mean, I remember early on, I would brick and blow up every piece of electronics that I touched. But that was a forcing function for me to really understand what was going on, how things worked, what I did wrong, and that forced me to actually really learn and take a breath and to figure out, how does this wireless radio work, giving it 5 volts instead of 3 volts, or something silly like that. But I think I think it was about this this kind of phase of the project, that really started to embrace failure. And I actually was, in a weird way, kind of looked forward to it because it was an opportunity to continue to learn and advance and look at things a little bit differently. And that was a mentality that I still carry to today. It's exciting when you hit a challenge. It sucks, it's brutal, but it makes me excited and want to persevere and solve it at a grand scale. So as you can see, the project started off very simple. Now it's starting to progress to, something a little bit more polished. This is also a project I named early on called the Robo Arm. And you can go online and download the files and 3D print it out of a consumer 3D printer. And my goal was to just kind of make a robotic test bed that you could maybe put something non-human, like a different end effector on the end of it, and use different controllers and different input methods for it all. And actually, a funny story: the arm on the right. We were invited to go on to a science channel TV show. What I think it was called American Makes, if I remember correctly, but it was almost like a Shark Tank maker combo. It was really cool. I don't think it went very long, but we developed at the time a complete EMG control system that you could use using your muscles, cycle through the different degrees of freedom, select it, and then move that degree of freedom based off muscle intensities. So that was just kind of an expansion based off just kind of normal software control with all that. But all of this led up to this really amazing moment. And this is at I believe it was the 2012 State Science Fair in Colorado. Again, little Easton running around. And for me, up until this point, this was purely just for fun and out of boredom, and I pretty much found my passion and just wanted to continue to make things and just kind of see where things went. But all of this led up to this amazing moment where this little girl came up to my project, and I noticed that she was missing her right arm and was wearing a prosthetic device. And for me, this was, I think probably all of us have had a situation where we've seen someone who's missing some sort of limb, whether it's a leg or an arm or part of their hand or finger, maybe at a grocery store or somewhere in public. That was pretty much my experience to the limb different community up until this point, where now I'm actually able to have a conversation with this little girl and her parents, and they were telling me about the process. This very simple open close prosthesis that was muscle controlled had taken months to create, which was a problem for growing children. And it cost $80,000. And I was completely shocked. I said, there's got to be, like, why? Like, there's got to be something there to, try and make it compute. But it didn't. And the more I looked into it, the more problems I found and challenges of this industry. And it's just a very stagnant industry that hasn't really seen innovation, is really built upon how much can clinicians bill insurance, and what probably started off as maybe a couple $1,000 arm quickly turns into something that is then billable for $80,000. And it really just exposed, taking my passion, and now I can solve a problem, a really relevant problem that is unfortunately only increasing around the world for many, many reasons. And from that moment on, I said, I have to solve this at a grand scale. And so I went back to the drawing board, started taking kind of this general robotic arm, humanoid robotic arm, and really started to look at the prosthetic market, the requirements. But I think a critical piece is not only looking at just the technology, it's the business model, it's the partnership, it's the distribution, it's everything behind it. It has to be a holistic, a critical look at this industry in whole, and not just, a little segment. And so, this slide is probably a couple years outdated, but there's probably at least probably 60, 65 million amputees worldwide. And only 5% of that number have access to any sort of assistive technology. And that's just not acceptable, I think, in today's world. I mean, I think it's pretty much as simple as that. There's an abundance of technology everywhere, cell phone, internet, all these different layers of technology. But where it matters most, as someone who, could be missing a limb, and how that affects the psychosocial aspect of life, the physical, just everyday activities of life. it takes a huge toll on someone, and that is what technology should be there to solve. Um, it made me excited, but also the more you look at it, you scratch your head. So there's a large range of prosthetic devices, ranging from just passive, something that looks human-like, all the way to these high-end, what's advertised as brain control, multi-degree of freedom, advanced robotic devices. Um, and again, you can go get the same device from 10 different people, and they're all going to be very different pricing, which was, part of the problem that we, hoped to address by this. So, at this point, I mentioned, popular mechanics, and I was, making, YouTube videos, and I was starting to get, some buzz online, and I was invited to to do an internship at NASA, working on the Robonaut project, working on the robotic hands of this robotic astronaut. The goal was to eliminate humans from ever having to go out into space, EVA, and instead just send robots that you could telerobotically control, which was really exciting. And that year, I actually ended up placing second in the world at the International Science Fair, which was mind-blowing from a tiny little town that I has never qualified, probably went never beyond state, let alone to qualify at an international competition like that. And then from that, a really special moment happened where I was invited to the 2013 White House Science Fair, where President Obama shook hands with one of the arms I made. And I think for me, it was amazing to see all these you know cool media things go on. It's always a lot of fun, but this was a really strange moment for me, as you can imagine. This is bizarre. Even looking at it today, it's odd. It's not a normal sight. But for me, it really changed how I thought about what I was creating and the impact behind all that. And it gave me a lot of energy, and it framed how I thought about creating very differently. Up until that point, again, I was kind of just making things for fun and tackling a problem that I thought was worthy, but seeing a world leader interact with something I make just changes things. So shortly after that, of course, there was a huge buzz, and I was very fortunate enough to be invited to give a TEDx talk that year, where I just pretty much laid out my vision and what I was up to, what I was creating. And one day, I get a call a couple weeks after, and it's a gentleman named Tony Robbins. And pick up the phone, didn't expect it to be Tony Robbins, calling my home landline, and he said, hey, I believe in. I saw your TED talk. I believe in your vision. I can't believe you're meeting world leaders, but still living out of your parents' bedroom. Let me help you take this to the next level. I think you have what it takes to solve this. And which was really exciting to hear from someone at that magnitude. So a couple months after that, pretty much right when I turned 18, the company Unlimited Tomorrow was born. So Tony Robbins was our founding investor and partner, and is still active in the company today. And this gave me now a credible platform to commercialize technology and partner with incredible companies, and ultimately get this technology to people that need it most. Um, but we didn't want to be just a normal prosthetic company, right? That's part of the problem. So we had to take a different approach. And it's something that's kind of our still, our mantra every day. It has to be user first. And I think it's easy to say, it's hard to execute. And it just has to be like deep in your blood, I feel like, as a company, to be able to put the user first. So I'll continue to talk about that during this talk, but it's a really, really big pillar. And then, address the elephants. I mentioned some of them, of just, the different billing practices and costs, and barely functional technology, and the aesthetics, and all these different things that add up to just kind of a sore product, if you will. And then I'd also say use technology for the right reasons. I think it's easy in today's world to be inundated by so many options and so many layers of technology, when you have to be really critical of, why are we using this? Is this really needed at this point? Right? Keep it simple. So that's always something that we're being critical of. It's easy to say, hey, let's throw AI at it or something along those lines. And not always the best case, even though it's kind of the world we live in. And then, as I already mentioned, focus on the entire problem, right? If we were just to make a prosthetic hand and put it on the market, this little girl, could have our hand, but it still might be a 60, $80,000 hand, and that is a problem for growing children. So we kind of broke this down. It had to be more capable, right? It had to be what we consider multi-articulating, something that you can reach out and pretty much with your eyes closed, have confidence that it's going to grab the object that's in front of you. Really lean on the mechanics and the product to do the heavy lifting and not all the cognitive computation to just pick up a glass of water when maybe if I have another hand, I can just reach out and grab that. Then that defeated the purpose, or that we lost some points on that technology if it's not easy to use and capable. Of course, it had to be lighter. That's a major complaint of current prosthesis is the weight. And it's not something you generally think about, but when you imagine, multiple pounds, now hanging off potentially a fairly short lever, that starts adding up and it changes. Can I go to the grocery store with this? Am I getting fatigued? Even when it's warm outside, when you sweat, you lose conductivity to a lot of the EMG sensors and the electrodes, which essentially renders the device useless. So, looking at things a little bit differently. Of course, it had to fit perfectly. The fit is one of the leading causes of rejection of device. If it's a little uncomfortable, you're not going to wear it, right? If your shoes, when you put them on, it's a little tight, but then when you start walking a mile in it, it starts hurting. You're not going to wear them, even though maybe it felt, good in some conditions. It has to fit perfectly in all conditions. And we're creating an extension of someone. It has to look beautiful. It had to be delivered faster, right? That's a problem for these growing children. And of course, it had to be affordable. And I want to start, kind of getting into, some of our amazing users. Momo was the very first recipient of our technology. And we actually partnered with Microsoft at the time where they made this beautiful kind of short documentary of Momo and myself and us ultimately coming together. And what we did, we were using Momo to kind of pressure test our business model. Could we send a 3D scanner to Momo's house where her parents could 3D scan her limb. And then we can take that 3D data and then using CAD and different, software tools, make a perfectly fit prosthetic socket, and then a prosthesis that matches her size and skin tone. And, that is the vision that we had at the time. And what was amazing is that I intentionally never had a conversation or met Momo up until the point of actually giving her her very first device. So it was a bit emotional. I hopefully this video comes through, you guys. You ready? Here's the
No.
moment.
Oh, wow. Oh, wow.
We even made some fingernails for you so you can like paint it and do all sorts of different stuff. And you can move the fingers too.
So ultimately, all of these things add up to what I define as a systematic change. The industry has never seen anything quite like this. And at the time, I think we really took it by storm. So I'd like to get into some of the fun technology of it all. There's a lot that we put into this, and I could talk for hours and hours about the entire tech stack. But the biggest thing that we leveraged was affordable, accessible 3D scanners. So these are 3D scanners that attach to an iPad that are a couple $100s that are relatively easy to use. We could ship it to someone's house. A family member would scan their residual limb and collect any other information that we need. To match their opposing limb if they have one, we used a method of using a known measurement, which was in our case a standard piece of paper, and have them take a top-down image. We could correct for any distortion, and then we could then measure all the different measurements of their hand, plug that into our automated CAD system. It would then generate a true limb to their proportions. And then we also had a skin color swatch that they could pick from hundreds of different skin tones. And then we would then 3D print that. At the time, we were using HP Multi-Jet Fusion 580 series machines. that could print in a PA12 nylon in full color, which is wild. So it had its CMYK cartridges, and it literally comes out of the machine looking like this. So it really changed the way that we could design robotics, and it was really kind of merging, kind of like humans and robotics in a lot of ways, right? This is a robotic hand that someone is wearing and it's attached to them. It has and for this design we had three actuators, one for the thumb, one for the index finger. Then these three fingers were tied together, and we had this mechanism that we internally called a teeter-totter, which was probably the best way to describe it. So it was essentially a tendon-based system. So you pull one tendon, these three fingers are somewhat connected, but they can also act independently and kind of teeter around a center axis of rotation. And so when you grab something, the fingers will automatically conform. It's all tendon based instead of linkage based. So each joint can act independent around an object. So more universality behind that. And I'm sure some of you are probably thinking, how does someone control this, right? So that's probably the harder piece of all of this. It's relatively straightforward to make a robotic hand, right? But how do you actually read meaningful data from a human body, and have that control something that is accurate and repeatable and lots of different conditions? That is a really, really tough challenge. And so what we ended up doing is we were the first company to commercialize what's considered force myography. Typically use EMG, which is electromyography. It uses electrodes and amplifies that through op amps, something you can read in software. They're very noisy sensors. Those sensors alone are considered a class 2 medical device. And like I mentioned, you go outside and you start sweating, you lose conductivity. Now it doesn't work. So we're trying to find a more universal way around this. And we said, hey, if I put my hand around my forearm, if I move fingers, I can feel things moving in different parts of my arm, right? You can almost imagine like a cross section of your arm, or kind of a heat map of, something around your arm. There's data there that correlates to what you're trying to do, and moving muscles. And what we did is we created a large array of force sensing resistors, FSRs, that line the entire interior of the socket. So now when someone puts it on, um, kind of a bad analogy, but years ago, maybe it still exists, but there was like a Dr. Scholl's thing at Walmart where you could stand on a mat, and it would show you kind of a heat map of like where your pressure points are. It was almost like that, except for your arm, um, you know, and pulling sensors thousands of times a second. And then we run all that data through an onboard, on the edge machine learning model. And then the output of that is robotic movements. We were pretty excited by how well this worked. It's something that a child would put their arm on for the first time, and about 10 or 15 minutes of calibration. Now they have full control. They can change grips, open and close. They have haptic feedback of when an object is in contact, all sorts of different things. So we were pretty excited about kind of all of that. And you can see there's lots of different combination, right? No two true limbs are ever the same. The size, the skin tone, the configuration, the socket, the amount of sensors that we put into it. Um, Here's a little bit more about our kind of model, our production model, if you will. So I mentioned we would 3D scan on an iPad, and then we would use we had a pretty large partnership with Siemens, which makes a software called NX, which is a really, really fancy CAD software. So that helped with a lot of the automation of being able to pull in a 3D scan and essentially conform pre-existing models to that scan and still be able to make adjustments. We would then 3D print a bunch of different sockets, a nominal, plus or minus, lots of different variations. We would then have a remote consultation. We would send them a simulated weight of the device. We really tried to think of it all to ultimately get to what we called a final socket as quickly as possible, and then ship them their device. And I said kind of a systematic change, right? We don't want to be a follower in this industry, right? We're trying to pave our own path. Um, Sometimes being a follower works out beautifully, sometimes it doesn't. This is an example of every one of these hands on the right side. They're all from different companies, but they all pretty much look and function pretty much the same, and they're all very expensive. And that was kind of an odd thing that we looked at. We were like, this is in the prosthetic industry, you buy a hand, then you have to buy the muscle sensors, you have to buy the battery, then a clinician combines them all, and it's a really staggered system. For us, we said, let's make a native, full, kind of stacked technology that is designed from the ground up to talk to everything. And I think the results speak for themselves here. And then here's just a little montage wall of all the incredible people that we've been able to help. And it's funny to look at, some people want it for really, really simple things. Maybe more of a passive device that they can just, walk around the grocery store and not get looks or just feel more confident in their body. Other people, want to do some really, intense things. We have a professional golfer that uses the device. This lady down in the lower left, she wanted a like silver sparkle arm, and we said, of course we can do that. And so now it turns into more of like a fashion statement. And so you never kind of know what people are going to do with these devices. We have people that ski with it and do some pretty hardcore things. And ultimately, I think through this journey, what I've really learned is to fall in love with the customer and not the product. And I've heard this before, and I've thought about it, but I think when within this line of work, it really hits home. This gentleman in the wheelchair, this is the first time, and I think in about 30 years that he was able to shake hands with his father. And it's something that when we produce the device, it's not necessarily something that we're thinking about or even know. But now what this technology and this product enables someone to do, that's why we do it, right? That makes us really excited. It makes us look at technology differently. Um, so I'm going to transition a little bit away from the prosthetic side and talk about our new product, which is called Tactreflex. It's a haptic glove for virtual reality technologies. Um, and I'm trying to think if there's any other kind of closing thoughts on the prosthetic side of things. Um, yeah, I think what we found the most is that it was surprising to us by the amount of people that wanted to help. And I think when you go into a product or a company or an idea, you think it's pretty much just yourself, and it's difficult, right? And what we started to do is we started to ask, hey, Siemens, can you help us with this? Can you give us some free software? Can you, X, Y, and Z, and go to different companies? And we were so surprised by the amount of people that wanted to help us and that came out of the woodwork. And early on in the company, we went through a couple of different unique funding routes. One was equity crowdfunding, and this was a pretty new thing. This was around like 2015 or 2016, I believe. And so we went to a website called Microventures. There's a ton of different websites, and what you can do, it's kind of like a Kickstarter, except instead of them buying a product, they buy shares of your company. And so that allowed, it was a pretty large success for us. We ended up raising about $1.7 million in about 30 days with about 1,100 investors. So, it's kind of a lot of investors to deal with in today's world. I would recommend it for some companies, other companies not so, but for us, it was a really unique way to activate just normal people that want to help, and that we were getting inundated with messages of people who want to help, and it was a really nice gateway for them to become part of the company and part of the product and part of the team. So it was really cool to kind of look back and see that. We've went through structured venture capital rounds in the past, convertible notes, kind of everything under the sun. We probably have gone through it. And yeah, it's been a really fun journey. And it's great. A lot of our investors have supported us through many rounds of funding to date. And I think it's just one of these things, if you're true to the technology and the customers and the market, and you can produce some results, more and more people want to continue to help. Um, so kind of the story of how we are now into the haptics market as well. One of our largest customers for TrueLim was the VA. And they came to us in the middle of COVID saying, hey, we love your technology. We're using it all the time. We have an issue that you might be able to help us with. We have veterans that can't travel to medical centers to get the needed therapies and services that they need. Specifically, they were looking at PTSD equine therapy. So equine therapy interacting with horses is a really great therapy for PTSD. Um, and their vision was, could we ship someone, veteran, a box that has a VR headset that you put on and gloves that you put on, and now you feel like you're interacting with horses, but it's all virtual. And maybe there's even some actual footage of that you can interact with. But the concept was, could you, feel the reins of the horse? Could you feel the breath, the hair, the maybe even the warmth, and start actually going through kind of a remote therapy like that. And so, we took a lot of our learnings of haptics from TrueLim, which we got really, really good at, of how do you decode, tactile information and how do you relay that back to the human body in a proper, high fidelity way. We just expanded on that. So we made a very basic version of haptic gloves that interacted with VR headsets. And we said, I think we're onto something. We've designed this in a pretty unique way. A lot of the other haptic solutions are very large industrial things that are $50,000 that need, large pneumatic tethers and generators and all these, very just large infrastructure required. And we found some ways that we didn't need any of that infrastructure. It could be completely self-contained on the gloves and work with the headsets beautifully. We've been in kind of a skunkworks mode for the last couple of years working on this product, but we're really excited to show you guys some of the new things. This new product is called TactReflex. And kind of looking at the problem statement, essentially VR is incredible, right? I think probably everybody on this call has probably played around with VR. It's probably one of the few crowds that I can probably say that in confidence. Um, and it's amazing, right? It does incredible things to your vision, to your auditory, and to your senses. But tactile is pretty much left behind, right? And it's a difficult thing. The controllers, they vibrate. It's kind of like a Wii remote, on steroids a little bit. But imagine if you could actually reach out and feel water or rain or wind or maybe you're in a chemistry lab and you can feel different maybe perceived weights of liquids or objects or feel liquid sloshing around in a beaker. And what would that do to your learning ability to actually physically feel something when you're in an immersive environment like that? It would only heighten the experience and make it more real. So we're thinking about all these different applications. We're really passionate about immersive learning because we think it's a way to really unlock some unique things anywhere in the world. But of course, video games is a primary market of virtual reality, of course. There's a lot of industrial and kind of like more government kind of simulations where you're working on really either dangerous or expensive equipment. Now you can do all that in VR, but you have that sense of touch, which makes it so much more real and can translate that into the physical world much easier and faster and probably safer within that. Um, so we created super, super lightweight haptic gloves, and we have kind of just talked about that. I'm gonna skip past this one. Um, I'll show you a quick video, and then I think I have a slide with some of the features on it. Um, this is just a quick video of myself playing around with the gloves, and there's a few things that you can notice. There's no tethers, there's no wires, everything is completely self-contained in the gloves. And so the biggest kind of feature set that we have is that we work natively with the built-in hand tracking on the newer headsets. You see a lot of these haptic gloves nowadays, and they have you strap, a controller or some other tracking, beacon, which is just a large piece, on the back of your hand, and that, then you have an awkward counterweight, and it's bigger, bulkier, it's hard to use, and everything like that. Our philosophy is, well, could we keep it within the human hand form factor and trick the hand tracking algorithms that this glove is just a human hand? And so it's a really tough engineering challenge to get into. But we're pretty happy with where we are right now. We have 22 vibration actuators on the surface of the hand. So there's about three per finger and eight on the palm. And one of my favorite demos to showcase this is being able to roll a small ball around your hand where you can actually feel exactly where it is on your hand. And now, mind you, you have the vision, the auditory cues, and it feels like the real thing. And then you can bounce the ball, and then you can feel the velocity of the ball, hitting and the impact hitting your hand at the precise location. And it's a really, really cool feature of it all. But through that, we can kind of augment different textures and densities and weights and different other cues through the vibration feedback. The force feedback, I think, is pretty remarkable, where we have tendons that run from actuators on the glove up to your fingers that will mechanically stop your fingers around the shape of the virtual object. So if I grab a virtual ball, my fingers will stop exactly around the virtual ball geometry. And now you can imagine, what if the ball is squishy? Now I can actually feel the material properties, the density of the object, and all sorts of different attributes like that. Um, so we're Unity based, so we want to make it really easy to integrate. We just came up with a new version, which we got rid of kind of all of the mechanics on the wrist, and it's all built into the back of the hand now. So it's very lightweight and easy to use. Um, and I think it's also like, like, why is now the right time for something like this? And I think this is also a topic I could talk for hours about, but I think it's the culmination of VR ultimately kind of finding its place. I think for many years the VR market was, it wanted to be there and everybody wanted it to be there as well. But I think now it's really found some true utility. And through that, there's, kind of obvious voids that now other technologies like haptic gloves can fill and really enhance the experience. So we're really excited about continuing to release this technology to democratize it, to get it to people's hands that can use it for all sorts of really cool creative things that we've never even thought about. And I think this has a lot of potential to impact people all around the world, whether it's for medical and surgical training to immersive education. Imagine taking chemistry or biology courses all in VR and being able to feel and interact with things. Imagine having a kind of a limitless resource environment that now you can play around with, and working with equipment that matches one-to-one to reality. It's all very exciting. And I think what also excites me is that all of this technology I look at is kind of in the infancy, right? So it can only get better. Like, what is the next version going to look like for True Limb, for these gloves? That's what gets us really excited. And what does that unlock for people to do and unlock, their potential as well? Um, just a quick summary of just kind of everything. I like to kind of condense my thoughts at the very end. Um, I didn't mention it, word for word, but I really like to embody clean slate thinking. And I think that was True Limb in a nutshell, where we almost had to erase almost everything we know about the prosthetic products and industry and design it, as a clean slate. What would we do if this didn't exist? Built around, user requirements, what would that look like? And I think that's always a healthy exercise to look through, is wipe everything off, put your tunnel vision on, and try and cut out all the external pieces that could influence what you're making, and be really critical. Continuous learning, built from foundations. I'm always looking. I always like to think about knowledge as kind of constructing a foundation where, okay, now I understand that I can write really good code in this area. That's my foundation. Now I can build on top of that, because I have a strong foundation, and now I can continue to learn and be prepared. Of course, fall in love with customers and their needs. I mentioned, don't follow the pack, pave your own path. That should get everybody excited. Technology is a force for good. I talked about kind of the technology can be a lifesaver, but can also kind of muddy the water in certain areas, and to be really critical about that and to be nimble. Partnerships and team, I only just brushed on that, but that is everything. I by no means do this by myself. It takes a world-class team and incredible partners and people that support you in many different capacities to make that happen. And it's something that you have to really get right early to be able to build really anything at a grand scale and solve meaningful problems and always be on the search for new partners and teams. And one of my favorite sayings is constant, never-ending improvement. I try and learn something new every day, whether it's something, silly or something that's, can really help me solve some of the current challenges I'm working with. But I think it's just always just, always try and grow as a person. And lastly, always stay curious, right? I think throughout all this, I really embody curiosity. And early on, I started to look at curiosity more as a tool than just a feeling or a thing. And I think that is something that when you are really passionate or, when something really strikes that curiosity thread, I'm sure all of us have probably experienced it where learning doesn't feel like learning, all the distractions, you're kind of in this flow state and it's amazing. And, trying to replicate that, find what makes you curious and, stay on that path and ultimately use curiosity as a tool. So with that, I will say thank you. And I think we're going to go into some questions.
So I have questions, but I do challenge the folks. Oh, so Chris, you have a question?
Yeah, well, thank you so much, Asen. You're very inspiring in the work that you do. It's incredible. So, thank you so much for what you do. So my question is, what surprised you as this evolved, and then you got your company going? What sort of insights in terms of getting this out to the world, surprised you the most, on this journey?
Hmm. Yeah, good question. I think there's two sides to it. One is there's just unfortunately a lot of red tape and things I'll kind of lump them under blockers. Um, like I want to say the FDA, but the FDA wasn't too much of a hassle for us. But what competitors did was that they would report us to the FDA to try and slow us down. And so, you could be doing the most altruistic thing in the world, and people are still going to try and slow you down and try and block you to some extent. And that's just I think that's unfortunately kind of the world we live in, even though I don't think a lot of people want to say that, but there's always going to be someone that's trying to block you or slow you down. So that was surprising. I didn't expect it, but it was also not necessarily surprising in that capacity. So, but then on the other side, I think it's also that I think in some ways underestimated what this technology did for people. We knew, like, you can think about it, but when we were able to talk and interact with people and see what they were doing with it, and it could be the most simplest things, right? Being able to hold a cup of coffee and open up a door at the same time. It just completely just blew us away. And especially for children, that was something that was just always really special. We knew that every device that went out to a child had so much just capacity behind what that could do for them. And it just gave us a lot of energy, throughout it all. So two sides of the coin, if you will, for that question.
Thank you.
Elijah?
Yeah, first and foremost. But yeah, congrats on your journey and everything that you've been through and made so far. But I guess my questions is more based like in the future. For starters, you mentioned that for the prosthetic project that you've had someone use it for golf. And so there was a football player in the NFL a couple years ago from 2018 to 2022. His name is Shaquem Griffin. He was born with uh, excuse me, amniotic band syndrome, which prevents his left hand from growing. And so he had it amputated very young, and he was still able to get to the NFL. So my question is, knowing that your product has been used for sports, going forward in the future, how do you see it being used in a sport like football? Because like I'm trying to imagine like the material, it could be like a danger because it's hard, but like do you see like a future model where it's like maybe hardened foam where it would be safe to use in a contact sport like that? And then same with basketball. So yeah, that's my question.
Yeah, great question. And yeah, Shaquem is a badass. He's a go-getter for sure. Yeah, I when I look at like the philosophy, like our design philosophy, it would be easy to try and say, let's make a prosthesis for football, let's make a different one for basketball, let's make one for, going shopping, and that is what pretty much the industry more or less has done, where there's activity-specific devices. So I want to go swimming, I use this thing, and to do this, to drive, I use this thing. Our philosophy is always trying to make a universal device, and that's hard because we know that we're not going to get every application. Like football is probably one of like the more extreme ones. I was even surprised. It's like, hey, someone went skiing with this. Probably wouldn't have advised them to go skiing with it because we haven't tested the forces of skiing with it. But also at the same time, now it's enabled them to go skiing, and so it's kind of like a fine line to like kind of figure that out. Um, but so the future, my vision for wearables, I guess in general, 3D printing is going to be the manufacturing method that unlocks any of these innovations. But I truly believe and have been a long time component of the multi-material 3D printing process. Being able to print in variable density TPUs and rubbers combined with very hard, rigid, potentially carbon fiber materials or, nylons, whatever combination for the application, I think is what's going to, be the unlock. And the machines are getting really, really good. I mean, I have some consumer end, kind of middle end 3D printers that can print in, many different materials at once. And for me, it was another unlock in my mind of, oh, I have a box that can make anything I could imagine, but now I have a box that can combine materials and colors and rubbers, and like that just changed how I thought about creating all over again. And that's only going to continue to happen faster with these machines. Right, there's only so many variables in these machines, and materials is probably the biggest variable that is only going to get better and better combinations that's going to unlock things. So for like a football device, that it might look like a normal hand, but what's in it is, layers of variable density rubbers on the surface, almost mimicking how we work, right? A strong internal skeleton that can take the forces, the outer surface to dissipate these forces, and impacts, core mechanics. So all these different things. I think that's where it's heading. And even for haptic gloves, I think it's also something similar where I imagine a future where the form factor probably doesn't even look like a glove. Is it something that just kind of slides on your hand or on your fingers, or is it just a wristband that could tap into different sensations and kind of tap into the nerve endings and pathways and all of these ideas. So I think it's a fun exercise, and to always try and like sit back and you know limit the distractions and think about, hey, what are those things? What could this unlock? Right now, I can print in rubber and rigid. Holy cow, that changes a whole lot. So, bit of a long-winded answer, but yeah, I think that's where it's going to be.
That's great. We're almost coming to time, so I did have a couple things. I was hoping that you might announce or let our guilds know what you're sending us.
Yes, I'm going to be sending you a couple pairs initially, and more to follow, of the haptic gloves to tear apart, have fun with, play around with, pressure test it, break things, use them in super weird ways. I ideally don't want to really set any boundaries, and would love just the creative flow and just the ingenuity to really showcase here. Um, and so I can kind of show you some of the things. So this is the haptic glove today without the outer glove on. So this is just the kind of the bare metal, if you will. So you can kind of see all these different lobes, all the different mechanics involved here, all the different vibration motors. We have some really clever mechanisms for the force feedback that will actually pinch the surface of your finger pad and not just kind of feel like a puppet. Here's like kind of this new improved um, kind of enclosure. So this is three micro actuators that run the tendons, battery, electronics. There's, USB port down here. Turn it on. We're going to be supplying an SDK with this to integrate it easily into Unity. We designed it in a way that you can pretty much drop the SDK into any existing VR experience or demo, and it should more or less work. But then we also want to continue to build out the SDK for new creations. And I would just say, please keep a very, very open communication pipeline. Anything that, you guys think would be cool or quirky or what if it could do this? Those are all the things that we want to hear for. Or if it's something like, why do you do this? Why is it doing it this way? Like those are equally amazing. So be very critical of it, if you will.
I am so thrilled, especially knowing your journey and just I feel like you're defined by the company you keep, and I just feel like Mesh Lab just got way cooler. I'm working with Unlimited tomorrow. I would like you to also just mention briefly your connection with ASU and how the two different ASU organizations that your counterparts that we met and just because I think that we probably have some entrepreneurial spirits here, and that it'd be good for them to know about who you worked with at ASU and who you're working with.
Yeah, absolutely. Yeah, we're actually getting very ingrained within the ASU culture very quickly. So I live on the East Coast, and that's where the company's been primarily for the last few years. But we see that there's so much energy and just talent in the Arizona area and the Phoenix area. And we really believe it's going to be the epicenter of the world, for technology and many other, facets, in the coming years. So we're really leaning into that. We're really bold on that vision. And so we're part of the Scale U program at ASU, which helps us scale internally within the ASU ecosystem. We recently went through the Invest U program, which we get to tap into some really incredible local angel investors that help ASU Invest U helps facilitate and support. We also received a grant from WearTech, which is a state-funded grant program that incentivizes us to develop, manufacture, do business in Arizona. So that's a really nice, financial assistance on that side. And then, now, partnering with Mesh Labs and, continuing to, look really critically at the future of VR and how it's used in education. It's something that we really want to continue to see forward. And really excited to ultimately get some gloves to you guys and, start the next chapter. So, I probably missed some ASU thing, but I know we're we're in
It's
it.
it's a many-headed beast. Any other questions? We're a little bit over time. Thank you again so much. Let's give a virtual and real round of applause for Easton. Yeah. Yay.
Oh,
I actually have to.
William had one last
Oh,
question if we have like a minute. Is that okay?
yes.
Yeah, it's a good
Um,
question.
yeah.
Um, yeah, so we are working on building our material library out right now. So I think that's kind of what you're looking for, where it's like, hey, this is a squishy thing, or it's a really rigid thing, or this has a glass texture on it, and how do we best achieve that? We have some really basic kind of starting things like that. But I think that's where the real development is going to be. Like one example, we have like a rain cloud that you can feel raindrops in our hand, and that was just custom scripted still within the SDK ecosystem. And like examples like that will kind of expose how you can best design for kind of custom features along those lines. So yeah, we kind of have it. We're going to continue to build that out more and more, but we also make it really easy for you to, make some custom sensations and things. So that's where it's going to be like we could work for years on, this kind of material library, if you will.
And I did have one last question. I know that you're working on different prototypes, and I think you answered this question for me in our last meeting, but just for this group, when do you foresee commercial production, like a full commercial production for this? And when can we start offering it, I guess, was my question originally.
Yeah, so our goal right now is to get pretty much as many units out in the field as more of a beta group. The technology is pretty locked in, like all of our electronics and motors, like everything is quite stable and secured. Um, it's just more of like, hey, after someone dons and doffs the glove 100 times, does this thing happen? Or, just like experience in the field, right? We need some miles on it. So that's really what we're aiming to do, probably over the next, 6 months or so. And then in that time, we're also working with local manufacturers in Arizona to start doing some small scale production runs. And then we would love for that to, potentially funnel and have you guys test out some fresh production units and kind of all that stuff. So hopefully you guys have an abundance of gloves and no time soon to play around with.
Fantastic. I am excited. New toys, y'all. Oh, William, you have so many great questions. Okay, you go ahead. I have to actually go to the meeting that Andrea just bounced to, but I'm going to just say thank you so much again, Easton, for your time. You can say and answer questions. I have to go, but so appreciate your time. I'm looking forward to our collaborations together, and this is just the beginning. So thank you.
Of course. No, thank you, everybody.